The James Webb Space Telescope has witnessed something truly amazing in the depths of the space. Magnificent lights, highly evocative of Earth's bustling urban areas, are transmitting from Proxima Centauri b, an exoplanet located 7 trillion miles distant. Are you prepared to face what's beyond the stars? Could we perhaps try to pause at some point and see if we can find a headway that isn't our own? What useful information may they, whenever they held, offer? And what does this signify for the future of humanity as the world struggles to make sense of this disturbing discovery? The latest data from the James Webb Telescope suggests something well beyond our current understanding. Could these lights eventually represent alert indicators from a high-level mission on Proxima Centauri b? Every flash and rapid advancement across this immense distance prompts conjecture that we might be on the cusp of the most startling revelation in human history: communication with an alien universe. This area, which was formerly thought to be calm and desolate, is now murmuring with the potential for life. As the telescope surveyed the boundless expanse of space, we came closer and closer to perhaps changing history with each new piece of knowledge we acquired. It discovered something endearing about Proxima Centauri b. The distant exoplanet appeared to have lights akin to those of large cities on Earth, raising the possibility of the existence of an alien human society. Researchers' excitement and curiosity have been greatly piqued by this idea, which may be the breakthrough they have been waiting for: the existence of sentient organisms capable of orchestrating their networks in ways that we have never before conceived. Columbia University cosmologist David Kipping described the planet where these lights were observed as especially intricate. This exoplanet behaves unusually because of its special interaction with its star, Proxima Centauri, in contrast to most rocky planets that receive sunlight and release infrared energy. This is where the intricacy lies. But this isn't the discovery's most astounding feature. The results of the James Webb Space Telescope demonstrate the true power of this instrument. These incredible lights demonstrate how much more is still to be discovered, and the telescope's ability to detect infrared light was essential to our observation of them. Understanding the nature of Proxima Centauri b's possible atmosphere depends on its signals. This telescope must be used indefinitely by researchers in order to investigate the planet's temperature and ascertain whether life is indeed possible there. Because of its exceptional ability to detect infrared light, the James Webb Space Telescope is able to examine Proxima Centauri b's nightly activity. The James Webb Telescope is capable of capturing even the slightest flickers of light, something that many space telescopes find difficult to do in the vast and blurry expanse of space. This makes it perfect for determining whether the purported city lights on the shadowy side of Proxima b are man-made or not. If artificial lights in space emit at a very specific limited frequency band and are significantly stronger than regular starlight, the telescope can detect them. Proxima Centauri b has a close interaction with its star. Its dark side reflects some light, while its star-facing side absorbs energy from the bright daylight. Like Earth, Proxima Centauri b goes through a continuous cycle of hot days and cool nights as it orbits its star. Large temperature differences are seen on the globe, mostly because to its location. In the absence of atmosphere, Proxima Centauri b would experience significant temperature differences, with the night side freezing and the day side becoming scorching hot. Astronomers are interested in these stark temperature differences because they may shed light on Proxima Centauri b's atmosphere. The James Webb Space Telescope is able to assess the planet's energy production, providing vital information about its atmosphere because of its excellent infrared imaging capabilities. The most intriguing feature is that Proxima Centauri b's orbit coincides with the telescope's orbit, enabling it to see the planet's regular cycles every 11.2 Earth days. The next stage is to examine the atmosphere of Proxima Centauri b to see whether or not life might be supported there. Compounds like as oxygen, methane, and water vapor may suggest that the planet is habitable. Finding these components on Proxima Centauri b would provide evidence for the planet's possible habitability, which would enable in-depth evaluations and studies of the light traveling through its atmosphere. The secret is that, for a more comprehensive view of other planets, the James Webb Space Telescope can also examine a few of the nearest worlds that are potentially habitable. The Extremely Large Telescope, ELT, which will start operations in 2028, is highly anticipated by researchers. It is anticipated that the ELT will provide more light on the possible composition of distant planets' atmospheres, and their likelihood of harboring life. Scientists are looking forward to the fresh perspectives that the ELT and other upcoming telescopes will provide. The James Webb Space Telescope is still an essential instrument for researching planets outside of our solar system in the meantime. Notwithstanding these drawbacks, it nonetheless yields important information that has the potential to transform our current and future understanding of the cosmos. We will continue to unravel these fascinating findings as we approach the next period, bringing us ever closer to some potentially monumental disclosures. In the future, space telescopes will try to filter out starlight so that planets around them can be seen more clearly. This is comparable to shielding your eyes from strong light by covering them with your palm. These sophisticated telescopes will be better equipped to capture the faint glow from far-off planets by lowering stellar glare. Researchers will be able to investigate these planets' atmospheres and determine whether they may host life with the aid of this sharper picture. But it's not an easy task. Scientists have to be very careful to identify gases coming from natural processes like volcanic eruptions from those created by living things. In order to properly detect indications of activity beneath the surface and not being duped by natural events, they must have a thorough understanding of these far-off planets. Future discoveries have new and intriguing prospects because to the James Webb Space Telescope, we are getting closer to knowing more about the huge cosmos and our place in it as long as we keep exploring space. We have questioned if we are the only species in the cosmos for as long as humanity has existed. Many researchers are still motivated by this subject today. The James Webb Space Telescope is now investigating far-off planets and moons in search of evidence of possible extraterrestrial life. The idea that life exists elsewhere in the universe is becoming more likely, and many people are excited about the prospect of discovering extraterrestrial life. Jill Tarter and Thomas Pearson, two American cosmologists, launched the Search for Extraterrestrial Intelligence (SETI) initiative in 1984. They established a non-profit organization with the goal of tracking radio signals from space in an effort to find evidence of extraterrestrial intelligence. They employed radio waves because they are a powerful transmission that can go over great distances without weakening. At the center of their study is the 42 radio telescopes that make up the California-based Allen Telescope Array. Even after listening for more than 30 years, SETI has not discovered any clear evidence of extraterrestrial life. Jill Tarter is optimistic nonetheless. She thinks that with the sophisticated technology of today, a big discovery might be on the corner. She sees an international endeavor to find out if we are the only species in the cosmos. NASA recently revealed that the James Webb Space Telescope may have observed artificial light from a nearby planet city. This news created a lot of excitement. An essential component of space exploration is the James Webb Space Telescope, which is located 1 million miles from Earth. It is made especially to catch information we have never seen before and returns extensive data about the oldest regions of the universe. This contributes to our understanding of the formation of planets, stars, and galaxies. Space scientists are focusing on the light from stars and planets using the Webb's sophisticated gear, such as its exact camera and specialized filters. Through the use of targeted light wavelengths, the telescope aids in the exploration of the chemical and physical composition of far-off worlds. But this isn't the most incredible aspect. Beyond simple observation, the James Webb Space Telescope actively investigates the atmospheres of many planets, looking for even the tiniest indications of life beneath the surface. We are entering a new era of discovery thanks to the James Webb Space Telescope's unparalleled capacity to probe the cosmos. Recently, scientists have discovered far more matter in huge galaxies than they ever imagined, leading to important new discoveries about the universe. These findings are forcing scientists to reevaluate current hypotheses regarding the origin and evolution of the cosmos. With every new finding made by the James Webb Space Telescope, our knowledge of the outermost regions of space and potential extraterrestrial life is expanding. Researchers are exploring space at a depth never seen before thanks to the James Webb Space Telescope. They are acquiring information on far-off worlds that may one day aid in the resolution of important issues regarding these exoplanets. Our knowledge of planets outside of our solar system was very limited just a few decades ago. Since then, scientists studying space have discovered over 4,000 exoplanets circling other stars. This demonstrates the power of advancement and curiosity. NASA estimates that there may be trillions more exoplanets out there waiting to be found, and they think these findings are only the beginning. Scientists are keen to discover potential extraterrestrial life hotspots as they carry out more space explorations. They occasionally come upon indications that point them in the proper direction. For instance, the Galileo probe unintentionally discovered something that might be vegetation close to Jupiter. This was an important finding since it was the first time that a biosignature, more precisely, the vegetation red edge, was identified. Using an analysis of light reflection, this method detects life. The James Webb Space Telescope will now concentrate on planets that orbit within the habitable zones of their stars in an effort to find extraterrestrial life. Our perception of the universe and our role in it may change if evidence of subterranean life is verified. With the advent of sophisticated satellite telescopes and observational methods, the hunt for extraterrestrial life has become extraordinarily difficult. Cosmologists are always pushing the envelope of what is feasible, and they are investigating if distant exoplanets could harbor life in addition to their physical characteristics. For this objective, the technological developments of the last few decades are essential. The advancement of spectroscopy, a method for analyzing light emitted or absorbed by objects in space, is one notable achievement. Researchers can ascertain the chemical composition of faraway exoplanets' atmospheres by examining their light spectra. This technique has already shown the existence of gases including carbon dioxide, helium, and hydrogen, revealing important details about the atmospheric conditions of a number of exoplanets. These findings aid in determining if the circumstances on an exoplanet might support life. The investigation of exoplanetary atmospheric conditions is another exciting frontier. Comprehending these patterns can provide hints regarding the temperatures and probable habitability of far-off worlds. For instance, identifying seasonal fluctuations in the atmosphere may indicate the existence of liquid water, which is essential to life as we know it. Extreme weather events, like strong storms or abrupt temperature swings, are also being investigated by scientists as they may have an impact on the habitability of exoplanets. There is a lot of attention paid to the hunt for biosignatures, or indications of activity beneath the surface. In addition to the conventional search for oxygen and methane, scientists are looking into complex chemical compounds and peculiar atmospheric anomalies as potential biosignatures. The James Webb Space Telescope is an excellent tool for this effort because of its sophisticated spectroscopic capabilities, which allow it to potentially find minute but significant indicators of activity below the surface. The search for extraterrestrial life relies heavily on theoretical models in addition to actual observation. Using well-established physics and chemical concepts, these models assist scientists in making predictions about the kinds of signals and circumstances that may exist on exoplanets. They also support the preparation of missions and experiments to verify these hypotheses. Exoplanet climate models can be used to guide future observational efforts by simulating the possible effects of various gases and environmental circumstances. Data analysis is also being revolutionized by the incorporation of artificial intelligence, AI, into space research. Sifting through the massive volumes of data gathered by satellite telescopes and other devices is becoming more and more common with the help of AI algorithms. By spotting patterns and abnormalities that human observers would overlook, these algorithms provide fresh perspectives on the characteristics of far-off worlds. Space exploration is progressing thanks in large part to international partnership. Global scientists and researchers are collaborating to exchange knowledge, materials, and data. This cooperative strategy accelerates the rate of discovery while improving our understanding of exoplanets. Going forward, one of the most significant problems facing humanity is whether or not we are alone in the cosmos. This topic should be addressed with more precision thanks to the ongoing advancements in science and space technology. The continued research and development in this area demonstrate the amazing strides we are making in our quest to learn more about the cosmos and our role in it.